We're going to be proving that lines are parallel today. Okay, so a few conditional statements here. If two lines in a plane are cut by a transversal and any of the following conditions are met, then the lines are parallel. So if corresponding angles are congruent, then the lines are parallel. If alternate exterior angles are congruent, then the lines are parallel. If same side interior angles are supplementary, then the lines are parallel. If alternate interior angles are congruent, then the lines are parallel. And if the two lines are perpendicular to the same line, then the lines are parallel. So for example, if the measure of angle 1 is equal to the measure of angle 2, we're going to determine which lines, if any, in this diagram are parallel, and then state the postulate or the theorem that justifies the answer. So looking at the picture here, they say that the measure of angle 1 is equal to the measure of angle 2. So that would mean that those two angles are congruent. The relationship between those two angles is that they would be corresponding angles because they're located in the same position on these two lines. The transversal in this case would be M. So this is our transversal. And these are the two lines that are cut by that transversal, R and S. So because angle 1 and angle 2 have the same measure or are congruent, we can conclude that line R is parallel to line S. And the postulate that guarantees that is the converse it didn't come out right, of the corresponding angles. On parallel lines. Alrighty. Okay, so for our second example, we're asked to find the measure of angle ABC so that line M is parallel to line N. So looking at our diagram here, here's line M, here's line N. So this would be our transversal here, line AB. And the measure of angle ABC would have to be congruent to the measure of angle BAD in order for line M and line N to be congruent. So let's write that down. The measure of angle ABC would have to be equal to the measure of angle BAD. Then I could substitute that with the algebraic expressions that we have for each of those. So for measure of angle ABC, we have 6x minus 20. For the measure of angle BAD, we have 3x plus 10. And we'll just use some standard algebra to solve that. So I'm going to subtract 3x from both sides and add 20 to both sides and then divide by 10. So we get x is equal to 10. Sorry, divide by 3, so we get x is equal to 10. The question, though, was to find the measure of angle ABC. So far, we've only found the value of x. So I'm going to go back and find ABC for my diagram here. That is 6 times x minus 20. And my x was 10. So 6 times 10 is 60, minus 20 is 40. So the measure of angle ABC is 40 degrees. Okay, there are a few guided practice problems here. This would be a great place to pause the video and then come back and see how you did on these. Okay, for number 1, the x value was 15, and the postulate used was the converse of the alternate exterior angles postulate. For number 2, x was 10, and the reason on that one was the converse of the alternate interior angles postulate. Next up, we're going to try the next 2 here. So again, pause the video, give these a shot, and then come back and see how you did. Okay, for number 3, the x value is 25, and that's the converse of the perpendicular lines postulate. And for number 4, x is 7. That was the converse of the alternate interior angles postulate. A couple more to try here. Again, pause the video, give these a shot, and then come back and see how you did. For number 5, the x value was 20. That was the converse of the alternate exterior angles postulate. For number 6, x is 10, and that's the converse of the corresponding angles postulate. Okay, so now we have a few more. Again, pause the video here and see what you can do with these. Okay, for these, the first bit of information they gave you was that angle 2 is congruent to angle 8. So looking at my picture over here, get a different color. Here's angle 2, and here's angle 8. So the relationship between those two is they would be alternate exterior angles. So line R would be our transversal there, so that means line L and line M would have to be our parallel lines. And because the relationship between those two is alternate exterior angles, this would actually be the converse of the alternate exterior angles postulate. Next one says the measure of angle 6 plus the measure of angle 13 is equal to 180. So this is essentially saying that angle 6 and angle 13 are supplementary. So looking at my picture, here's angle 6, and here's angle 13. So these two angles, the relationship that they have is that they are same side interior angles. So line M would be our transversal this time. Line M is cutting through lines R and lines S. So R and S would be the parallel lines. Next statement says that angle 15 is congruent to angle 11. So again, I want to show that on my picture. Angle 15 is here. Angle 11 is here. The relationship between those two is that they are corresponding angles. They're in the same position on two different lines. So the transversal this time is S, and that would mean that lines L and M would have to be parallel. That one's by the converse of the corresponding angles postulate. And the last one is angle 14 is congruent to angle 12. So angle 14 is here. Angle 12 is here. Relationship between those two is that they are alternate interior angles. So S would be the transversal, and that means that lines L and lines M would have to be parallel.